Hello, good evening, everybody. I hope you can able to listen me. This is Bernard here from LDS Technologies, and if you have any queries, you can just chat it off, and if you have any doubts, you can chat it off. And probably at the end, we will give you an option of asking the questions so that you can able to ask the questions in between. All right. I guess it's very clear for you people now. So let us start today's session. Okay. So as you see, this is the third session in the row in the series where we have covered uh, most of the topics. I'll recap what we have covered the last time down the line, and probably we may have one more session for the series also, where we'll be covering more on wire routing also. All right. To start with that, yes, I'm Bernard here, representing Delivery Readiness, having 18 years of experience in the training and competency development, where I'm a Dassault System certified instructor in terms of CATIA V5, where you can see on my screen. Okay, hope it's very clear and audible. So any point of time, you can just chat it. Okay, thank you very much. So what is what's for you today is that, just a minute, I make it my screen run. Okay, I think you can able to see my screen now. Okay, what's there for you today is that at the end of this webinar, you can able to know electrical harness flattening terminologies, the process and the practice of EHF, and how to generate a report, and the manufacturing drawing documents. So finally, how this manufacturing drawing documents are created in CATIA V5. So these are the takeaways which you will take it at the end of the sessions. Right. So the objective of what today is that what are the challenges typically what we have it in the industry is that multiple applications, the data sources are different, and sharing of information and integrations across the team is challenging. So how we the PLM domain or CATIA, how it's satisfy the requirement in the terms of delivering the product. Next is always when we take that, we have some repetitive time consumptions and error, which are very complex and which will challenges to current industry standards. So which it is very important to use digital manufacturing or digital informations for validation of your product design. And third is about the poor integrations with the electrical systems, especially with the ECAD and the MCAD systems, which defines the quality of issues or quality status, or there is a disconnect between this ECAD and MCAD. So this is one of the challenges. And finally, there's no association between the 3D wire harness and the manufacturing document, which always EBOM and MBOM, you have these challenges. So this is about the objective of today's, where you can able to see the session and how exactly we can able to take it up. Okay. Before we fly in, yes, I want to just tell you, you can able to see us in our LinkedIn, social media, where Facebook, LinkedIn, Twitter, and YouTube, where we have plenty of recorded videos already. What are the recorders like electrical harness or composites or sheet metal design, aerospace sheet metal, all this content are there, and all the current technologies and recent information about what is there, you can find it off. Okay, so this is how we believe in that you can connect to this social media and try to explore more of what is with EDS technologies, right? And recap about what we did until last session, and it's all about we spoke about the different industry usage in terms of harness system. It can be aerospace, or it can be in terms of automotive or fabrications and developments. It can be any of the systems. So why electrical harness plays a major role in terms of in the different segments of industry usage, especially when miles of wires are or kilometers of wires are used. How can you optimize the length and of the cable or the length of the harness, and how you optimize the entire system in terms of electrical harness. That's the reason what we defined last session itself, that electrical harness is a digital markup environment where you try to create all this in a virtual environment and validate with the physical one. So if you take any of these industries, yes, electrical harness plays a major role because optimization is the biggest challenge. So that's the reason we tell that CATIA V5 DMU, uh, that means CATIA V5 electrical harness as a mock-up environment where you can able to see the 3D information of your product design. Okay. What was the last recap? This is the recap which I wanted to just showcase to you people before going to the next slide. Okay, introduction to terminology aerospace. So last session we covered what is geometrical bundle, what is branch point, what is bundle segment, and how this is very important when you do harness systems, whether it is aerospace or automotive, whatever it is. These are some of the terminologies which you need to understand about this one. And catalog of components where you have standard components, where you manufacture and reuse whenever it is required, and you have something called as you put those equipments and mounting equipments. It's all of your panel board, which we use it for your references, and all your support, which carries your harnesses. So if you see there, these connectors to equipments, okay, so it's connectors to equipment to mounting equipment is all about your supports. And so all this is all about your harness device connectors. All these devices are made, and this is what we call it as harness connector supports, which you make it is called as a harness support. And in fact, when we do it, we use it protection like tape or corrugated tube to as an insulations, which we need to do it. A very interesting thing which you can see is always your support is being carried away by the protection tapes. So that's a very important thing which you can see that. So, okay. So next about the automotive terminologies, where you can able to see same thing, geometry bundle, connectors, equipments. You talk about corrugated tubes. What is the difference is that all the equipments, your battery, hydraulic system or pneumatic systems, or even the heat informations, or all these are the same format. One thing is the protection tape or corrugated tube, which is called as a texture. And this is the terminology which use it. And last session we covered all the stuff. Okay. And general in terms of your fabrication is you may have some, say for example, you may have some washing machine or all the stuff, how the connectors are plugged in and how the connectors are used and how the supports are used to hold the cables rigidly. So there is a process where you can able to find out the entire process of how to handle your electrical system. So to just brief out, we made something called as electrical part design, where you connect all your standard components and convert into harness systems using electrical harness assembly. So to say about what is electrical systems and development processes, CATIA are predominantly take care on the physical design and a bit on the wire logical design and the manufacturing documents. And if you see, we have covered something on the space reservation that's very important in terms of DMU, as we tell about. And you have something called electrical harness installations, which we define the harness of each and every components. And then finally today's session is all about your harness manufacturing and form board sessions, so which is all about the electrical functional design. And this is all about electrical spec, which we covered as a process. So you need to understand that when we execute any of the projects, where you stand first. Either we are working on the space reservation area, or we are working on the area, or else we are working on the harness documentation. Okay, harness documentations. So these are the areas where you can able to see that and able to find out their importance. Okay, just a minute. So when any project lands to you, you need to understand whether you are working on the harness installation or documentations or wire routing, ECAD, MCAD integrations. That is also very important. So based on that, you need to classify what sort of licenses you need to use it. So that's the recap which I just want to tell you from last session to this session. Okay. So to say it simple, in electrical or automotive simple, what is functional, logical, and how your electrical systems will work and how the manufacturing document will work, and the entire process is all about integrating your electrical process. Say for example, your functional and wiring diagram can be any other applications. It can be Autodesk product, or it can be C Electrical or Zuken or any of the products where you have specifically ECAD systems where you can integrate those into CATIA V5 by bringing them in a neutral format, and maybe making a map between the naming conventions of other applications to the CATIA applications. So that is what we talk about, the integration of different processes, and how finally you want a manufacturing documentation, because the manufacturing team just wants the cable diameter, length, and spec from where to where. So that's the importance, what you need to understand here in manufacturing. So that's what I was just telling you about the Zuken or IGX, which is our Dassault System business partner products, and we have a component catalogs where you use CATIA V5 harnessing. That's the symbol what you need to keep it in your mind, that this is about your wiring information, wire route, all about your harness installations, and all about your catalogs, which you share it and save it in that format. And it's very interesting that in last session I covered something where catalogs you can convert to your standard components. No need to design a model. You can use some IGS data or step data where you can download from the OEMs, those who are manufacturing standard components, and convert that into an electrical definition product. So I think that is the key thing which we covered last session, and today's we are going to cover much on the manufacturing side. The simple format for fabrication industry is also where you can able to see that you create your standard components, you create your connectors supporting catalogs, and convert those into, put it into catalog, and create a harness, route your wires, install that, and finally you need to create a manufacturing documents, which is a simplified process. And this is the process which you need to understand that while doing any of the electrical harness assembly. So you may have standard components, put it in a catalog, do the harness, and do the wiring informations inside the cables, and give the manufacturing document. Manufacturing document in the sense, it's all about electrical harness flattening. It's all about flattening, which I'm going to cover today. Okay, so this is how the process is all about that. Okay, so today's session more is all about your electrical harness flattening, where we are just going to define the 3D form board and the 2D drawing information. What is 3D form board? 3D form board is all about your 3D diagrams, 3D models of harnesses, where I'm going to flatten it with reference to some reference planes, and from that I'm going to create a 2D drawing. So remember, electrical harness flattening is not a 2D, it's a 3D form board. So it's nail board, where you remember, you might have seen in some of the NGC channels where they used to measure the snake length, the similar format, I'm going to measure the harness length. So that for the manufacturing team, I'm going to just cut that cables and give to them so that you take it up. To say simple, what is the cables you use it in your computers today? It's all ready-made. Just take it up, you connect your monitor to your keyboard or your CPUs, all the stuff. It's all the standard components. It's simple like that. So manufacturing team wants such information where ready-made cables are available, which is called as a modular design. Very important point, modular design. Any point of time, any cables goes off, what you do is you replace by other one, not replacing the entire system. So that's the advantage of electrical harness system, and that's the manufacturing document which you need it. Okay, and what is that? This is the old method which we all will. This is the method where they used to measure these systems. So now electrical harness system is all about getting into the system. So what is electrical design? Once again, just reframing you. Device management. It's all about a device. You have a, for example, the washing machine. Your washing machine will have a motor, and it has a motor. It has other components, electrical components, all these are devices. It's called as a device management. And all these devices are connected through harness, which is called as a harness definitions, where you need to connect all your harness informations. And now it is all about your related relationship objects, where you need to connect all your catalog editors, catalogs, where you create your standard components and store it up. And now probably next session I'll be covering more on wire routing, how to interface your wire inside your bundles, where you are going to connect your logical systems, and finally getting into the harness flattening and documentations. Harness and flattening documentation, it's all about the parameters where you're going to documentations, purely on the documentation side. And deep dive more into electrical flattening harness. What does that mean? It's all about your flattening commands. Like, we are going to tell about your flattening components, where you have something called as a parameters. Okay, you have something called as where you need to extract it. I will tell you what I mean by extract, flattening. I'll show you a demo how exactly it is going to happen, and then you can create a report, a drawing report. And very important, the drafting integrations, where you can integrate your drafting and annotate it. And all this are stored in the catalogs, even the drawing template. What you need to do it, you can do it. And you have something called generative view style. It's very important word. Just make a note. You have so many information in YouTube about what is meant by generative view style. I'm not going to cover here today, but you can just take it out and make a note. What is meant by generative view style, GVS system, where automatically you can rename it. Okay. Is there any doubt, so that you can chat it? So until now, if it is okay, I will just proceed it. Okay. So what exactly the harness flattening is all about, this, where you have a harness flattening, you're going to extract it, and you're going to flatten it, and finally you're going to do a harness drawing sheet. So someone was asking in the initial stage, what is harness flattening is all about? Harness flattening is all about, you have a 3D components, extract those components, flatten it with reference to some reference planes, as you see in this picture, and finally making a harness drawing information, where you can know the spec of each and every harness, which I'm going to show you today. So starting with electrical harness terminologies, what are the things you need to understand when you start working on electrical harness terminologies, especially on the flattening side? We have something called algorithm mode, and we have algorithm mode where we talk about two things. One is coarse mode and fine mode. Okay, the coarse mode is all about your 3D harness, how you say it. Roughly it straightens, that's it. And the fine mode respects the actual part. For example, the coarse mode is all just to give you a documentation purpose. So you can set it. I'll show you in a CATIA as a demo, but just to understand, coarse mode and fine mode. Fine mode means as you will be there. Say for example, you may be wearing a headphone and listening now. That headphone, what is the harness which is connected to your laptop is all about the fine mode, and your component will be looking like what exactly the fine mode is all about. Coarse mode means it becomes straight. Your cable which is connected to yours becomes straight. That's what about the coarse mode. Now extract, what are the things you need to extract? A very important thing, this is when you extract the geometrical bundle, you know what I mean by geometrical bundle, which consists of all the harnesses. And when you extract it, it's very important that you need to extract all the associative connectors, backshells, and connects and supports. So that's very important parameters which you need to set at the initial stage. Then flattening, flattening of electrical harness allows you to flatten the geometry with reference to certain segments, certain bundle, with reference to some nail board, where you need to define the length. Sometimes what happens, your cable, one of the cable bundle length will be beyond the limit. Say for example, it can be in kilometers, but you want to put it in a drawing sheet. So what you need to do, you can put it fake length so that you can accommodate this into a drawing sheet and start fitting to your requirements. So, but it gives the original length, but just to reduce the fake length, just like a dotted dimensions. So that are the settings which you can do it. In fact, I will tell you in detail about that. Synchronization is all about very important thing. So what is synchronization is, flattening is nothing but when you start flattening, you're not going to flatten the components which are non-electrical device. I mean to say panel board is there, from panel board I'm going to extract only the harness. So any changes you do down the line in the 3D harness in the master data, so it's going to get changed here. That's what we call about synchronizations. And generative view style, where automatic drawing creations, catalogs, informations, dimensions happens there. Okay. So these are some of the things which you need to understand first in terms of CATIA electrical harness flattening. All these factors are available, parameters which we call are available in a tools option parameters, just to make a note. So I'm going to the next. What is this parameters? Electrical first, you can just see that. What is the parameters? So it is simple like what you, if you have people have worked on sheet metal design or aerospace sheet metal design, you need to give them thickness. That is a parameters. So parameter is all about clicking the sheet metal information, all these things. Similarly, harness flattening means with reference to which plane I'm going to flatten it. Default it takes XY plane. That's what. I explain what is coarse mode and what is a fine mode, and these are some of the things which you need to understand. And what is standard, regular. Each and every time when you start taking the extracted harness into the drawing sheet, what angle you need to bend. So these are some of the information which you can take. That's what I was just telling you in the next slide, where you can see coarse mode, what is fine mode, and what is regular mode. So coarse mode is number one, straighten the flattened bundle and geometrical bundle or this is good to prepare only a harness documentation. That's very important. And number two is fine mode, where to respect the shape of the bundle as you see that in a 3D. And the two angles, that's what we talk about, standard mode and regular mode, where it accommodates the angle of information. So that's the general parameters which you need to understand. Now, this is very important. When you flatten the component, we need to understand the flattening scaling, where I can make it two things. I don't want any scaling, number one. Number two, I can scale it. It's scaling means it's not like 1 to 2 harness, 3 harness, 4 harness. It's all about the length. It's all about the length of the cable scaling factors. So you just take one of the cable which is 100 meters or take 1000 meters. So anything goes beyond the 1000 meters, you need to reduce by certain percentage, 30% or 40%. And if you have any harnesses where the number of components are numbers, in terms of numbers, you need to reduce that. So that is how you consider that into factors. So scaling factor is that. And finally, what we talk about is all about the synchronization, which I'll show you how to synchronize your master data with the 3D. And flattening report generations and drawing creations, where this is very important, where you need to define your report, and those reports are going to get it into a drawing where you can get it. So what is that you need to create for a report? Say for example, when I want to take the harness into the drawing, so drawing, I want to put an information about in a CSV or information that my drawing report should consist of, just think in a manufacturing company or manufacturing supplier, what he wants it. He wants what? Nothing but the bundle in name, the diameter, the length, and or what are the factors like bend radius, all these factors. So this is what. So you need to generate a report at the back end so that it reflects on your drawing sheets, which I will showcase now down the line. Okay. And finally, this will be your results, where you can able to see the results finally. This will be a manufacturing document. Okay. So this is the flow which you need to understand in electrical harness, that when you start doing electrical harness, remember that until you get a documentation, your electrical harness system is all about that. Okay. So just I'll get into a demo. If you have any queries, you can ask me now. Okay. So, all right. Fine. I'll get into the demo now. So hope you can able to see the my CATIA screen. Okay, so let us start it. I know that in terms of any point of time, if you are not able to see the screen, I'll repeat the process. Okay, so how to get into that? So what we discuss now is equipment, electrical harness flattening. Okay, so this is what we talk about, electrical harness flattening. So now let me get into electrical harness flattening and showcase how exactly the harness flattening is all about. So before doing to that, I will teach you how to create a template, a drawing template in electrical harness systems. So what I'm going to do it is I'm just getting into a file. I'm getting into a new, and I'm going to have a drawing format. Okay, so where I'm going to get a A4 drawing sheets, and I'm going to create a template which will tell you that this is how the drawing is all about. Okay, so once I create it, you can see that you can insert a link. This is what we call an insert a link template, where you can create it. And today we are just working on electrical systems. So why this electrical text template is required? Remember, I told you, when you take the harness and bring it to a drawing sheet, you want naming conventions. Automatically, I don't want to write it, text it for each and every bundle. So to do that, I'm creating a catalog where I'll save this one. So I'm just going to create an electrical bundle. I want the spec of this bundle to be as length, for example, length. Name, I'll put it first. I'm going to insert it. So you can hold shift, enter, so it goes to the next line, and I'm going to put the diameter of this. So I'm going to click here, the diameter. I'm going to insert it, and I'm going to enter, shift, enter, and I'm going to put it here as length. So these are the informations which I wanted. And give OK, close it, and give OK. So this is the template which I'm going to save it at the back end and try to use it down the line. So what I'll do now, I'm going to create a catalog, file, new. I'm going to create a catalog, give OK. And I'm going to create a catalog in electrical systems. You can make it here like electrical systems. Okay. Give OK, fine. You get here, and you can see this component. So what I'm going to do it is I'm going to select this component, and before that it's very important that you need to save those components. Okay, so what I'll do, I'll get into this drawing and I'll save this one, file. I'm going to save this. So for example, I'm going to save this as a drawing. And I want to put this drawing file into catalog. So what I'm going to do it is I'm going to jump onto catalog, which I did just now, and I'm going to click on this one. I'm going to select an external feature. Just click on this external feature, where you can able to select the this drawing, and you can template as, say for example, BNS bundle segment details. So just give OK, and you can see the preview. Your catalog comes. It's simple like the catalog what you create for bold and nuts. It's a similar format. But here I'm going to create a text template of this one. You remember this is called a dictionary, feature dictionary. Okay, so now save this as a catalog. You can use it this. So I'm going to save this as a catalog. Okay, so this is how I create the definitions of these catalogs and save it for my references. And down the line, I'm going to use this information for detailing my references. Okay, so let me start with what is the flattening. So the first requirement, what I did is just a drawing information template catalog creations, which you understood now. So just to repeat once again, insert it, go here, right click. Okay, so just do this one once again, right click, insert, in template, you can able to do that. Okay, so I'm just going to close this. So I'm going to open exercise where you can able to see that this is my component where I want to showcase the information of your data. So It takes time to open. Yeah, you got, yeah. Hope you can able to see this information. All right. So this is my harness which I've done already. Now just I want to do the flattening. I'm going to do it is, so you see here very important is that um, the component. Now this is EBN. EBN reference to electrical uh, bundle segment. So this EBN will have all the informations of wires, and this is GBN. GBN is the geometrical bundle segment. So this EBN is all about your wire routing information. Okay. So now what I want to do is that I want to extract this and create a component. So to do this, what I'm going to do, I'm creating a new product. So new product. Yeah, okay. And I'm going to make it Windows vertical. So you can see one side the original harness is there. The other side you can see the components. I'm just waiting for the screen to go. All right. Be able to hear me, please? Yeah. Yeah. So you can see this two screens now, where you can see my product, a new car, which is I've done the routing, all this. So here I have EBN and GBN. So if I want to extract, either I can do EBN as well as GBN also. You can do that. So if you see here, my active screen is now this one. This is product 6, where you can see that I'm going to create a definition. You can see that none of the commands are active now at the bottom because we need to define the parameters. So what I'm going to do is that I'm going to create a definition. See, I'm going to create a harnessing informations. So this is what I was just discussing at the initial stage. What is general and what is flattening? What is flattening scale? What is synchronizations? What is drawing informations? What is general information? With reference to what plane I'm going to create a plane. So coarse mode, standard mode, we got the informations. What is flattening orientation? When I do the flattening, is it the devices which are connected at the end? Devices in the sense the component which are connected at the end. Do we need to do the flattening of those components also is required? We need to check on that. Okay. So that is what we talk about, the flattening. And scale, which we talk about, all the components, if it is 30% more than that, we can reduce it. 100 mm then we can reduce. Synchronization, how it's synchronized. And in fact, we can give the default tolerance also. For example, manufacturing will tell, give 2% of tolerance. You can set that here itself so that you can take it up to the next level also. Okay, so I'm just getting into an extraction mode where I'm going to extract this one. So what I'm going to do it is I'm just going to click on this and I'm going to activate, okay, I'm just giving activate as if like that. Now you can see all your commands are getting activated, and I'm going to extract what? I'm going to extract here my EBN or GBN. So both are synchronized. So I will just take my EBN itself. So what I'm going to do it is I'm going to extract this into this particular product. So once I click extract, what happens is all the harnesses, only harnesses, not the door, everything comes and sits in the product 6, which is referred as a, so you can see that now. So you can see fitted. So you can see I'm going to update now. So all the products, whatever you see, except the door panels, all the connected components will come and sit on that. So this is what we talk about harness flattening. So this is what we talk about harness flattening. Okay, where the harnesses from here, from the root product or the master geometry. I'm just master product. I'm going to extract it. Now what I need to do it is I'm just going to use this. That's it. So in this I can insert some panel board or nail board format information so that it is useful. So I'm going to insert an existing component into this. So I'm just going to insert it and I'm going to use something called board. So I'm just going to insert board. So once you have this board, you can see that your board has been created and it's brought in here. Okay, your board is here now. So if you see this, the entire harness system is that you just see it's not flattened. You can see that it's not flattened. It's just crossed this way.
Sorry to interrupt, sir. There is a question from Mr. Gaurav. Can you repeat that one again?
Okay, I'll repeat it. It's very important. So I'll just do that once again. I'm just going to close this. Okay, I'm going to create a file, new product. I will be a bit fast. You can just go there. This recording will be available for you post the training, post the webinar. You can use it for your reference purpose. Okay, I'm going to use vertical. Now what I want is that I want to extract this harness from here to there. So what I'm going to do it is I'm just going to extract. Okay, so you can see that flattening comes here. Okay, once you give it, the flattening parameters comes here. Then what I want to extract here, I want to extract the harness. I'm going to click on the harness. Now which is active is product 6 is active. Okay, I'm going to extract which one? This EBN. So once you click on this EBN, automatically your harnesses which was there here gets extracted and it appears in the product 6. Now what you need to understand from this is I've just taken only the harnesses and bring on to flattening module. Okay, so you can see here, sorry, you can see that I'm going to fit in where you can see all your harness components fixed there, including this. So only the harness is come in from the root product data, master data product, because I need to work on this particular component only. So update it. So once it is done, so then you can start bringing your components, your flatten. Just to make you understand, I'm going to bring a form board, just to make you understand. Okay, or else you can flatten with the reference to that itself. So I'm just going to insert existing component into my root product. So I'm going to use a board. This board is just for a reference. It is not required that you need to do this. Just for making you understand, I just brought this. Now, when I did this flattening, I made it something called flatten parameters. So this parameters was with reference to XY. But now I need to do the flattening of the entire harness with reference to this face. Okay, this face. So what I'm going to do it is, I'm going to click on this face, and instead of this XY plane, which is their default, I'm going to select this particular face. So once I select it, you can see that it's a face, which you can see that. Now give OK, you get that. Okay, so now what I'm going to do it is I'm going to just flatten. It's not flattened. Okay, until now the components are placed in a board, just like your references. Now what I'm going to do it is I'm just going to flatten that with reference to this particular board. So what I'm going to do it here is I have something called as electrical flattening. So just select this flattening, reference to this. Which one? I'm going to with reference to this face and give OK, you get it. Give OK. So now what happens is that your harness gets flattened with reference to this particular board. It takes time to visualize it. I think you can see that. Okay, so I just selected that. It gets flattened. Now if you see that your harness is got flattened with reference to this particular board. So you can see that. Fine. Okay, now what I'm doing is I'm just to make you understand, I'm making this to move down so that it's very clear for you. All right. So now it's your requirement. Now how you want to represent in your drawing sheet is all about. So say for example, I want to put this drawing sheet in a form board. This is all of your customer requirements. I want to arrange this particular as in this junction point of view. Just give OK. It will arrange it. So you need to understand the red one which is getting updated is all about your protection tape, corrugated tubes. So how you want to organize in your form board is all about that, what you see here. So I want to just quick roll this component. So I will make it other direction, sorry. So I'll make it so you can see this. I can make it this way also. Okay. Or I want to just bend this one. So I want to bend this particular, I'm going to use called roll. So which one? I'm going to roll this one with reference to this one at an angle of 42 degrees. See this? You can just do that. So how you want to customize your drawing sheet, the representation of your 3D model can be done. So this is how you want to represent in this format. So similarly, I want to rotate this component. So what I can do it is I can do a rotate of this particular component. So I want to rotate like this. So just a 42 degree. I'm just giving a hint like this. So 42 degree. I just want to move this because I want to align it to that. So this is how you make your harness representing in your drawing sheets. Here similarly you want to give scaling factors, you can give the scaling factors and you can synchronize it. Okay, so here you can see a quick roll, bend, how you need to align your components. Say for example, I just try this one, take this one, take other one, apply this particular loom and I select it with reference to that plane angle. It's all about how you want to represent it. Okay, so this I think you can able to just you have something called scaling factors where you can able to scale those components called a scaling. Just click on that and you can able to it, apply it, it becomes. So as I told you initially, you can able to control that. So this you can control in other format also, like for example, you can get into this parameters, tools, parameters, and here you can go to scaling factor where you can select here scaling factor. Anything goes beyond 100 mm, reduce to 30 mm. So if any dimension is going beyond the limit, reduce to 30%. So you can set it like that. Or in a loom, if number of looms or number of bundles are more than 30, reduce to 30%. So you can do this particular scaling factors also. So no need to do by individual. So you can just set it, anything crosses 100 mm, reduce by 30%. That means if it is 100 mm, the original length will be 70 mm. That's the meaning of that. Okay. Okay. Now, how to generate a report? So just get into my tools, go to reports. I want to define these reports. Okay. So before that, I can just show you any dimensions you do this changes here. What we talk about is all about your synchronization. What is meant by synchronization? This is what we talk about synchronization. So anything I do here in my electrical root product, I mean the root product, say for example, this is my cable, now this is my bundle, and change it to 1 mm. Apply it, give OK, and update here. So I just change it, the component from there to here, just slack. So the same thing should have changed in the product also, here also. So it won't do that. What we need to do it is, you need to synchronize it. So just synchronize it. So before that, I need to save that. So bundle it, give OK, it gets synchronized, and you get an information. about synchronization. A report. Every bundle has been synchronized. You can see that at the bottom. Okay. So everything is in. So this is how the synchronization report is generated. So no need to do anything. Whatever you do in the root product changes, just come here and click once synchronization, it gets synchronized. While you synchronize it, what you want to synchronize? Is it your connectors, or is it your bundles, or your other stuffs like splices, all the stuff? Okay. So this is how you create your synchronizations. Hope you can understand all the basic functionalities. Just 1 hour, I'm just covering what are the key factors which you can do it of. I mean, separately we can have it based on the requirement down the line. So now I'm going to tell you how the report is going to generate, which we discussed initially. So for doing this report, you need to define it and you need to generate it also. Okay. So what I'm going to do it is I'm going to just use Control F. So because I'm going to create a query, Control F, you know that already, you may be using it. So I'm going to create a query in advance where I'm going to create a query in electrical. Say for example, I want to use it for electrical. In electrical, I want to use something called for, say for example, bundle segment. And I want to have an attribute where I want to see the fully connected. And I want to give OK. So this is my query which I created just now. Okay, what I created in electrical workbench, in a bundle segment, and attributes fully connected, for which I want to make it query, and I'm going to select here called as search. So once you click here, you can create your query, and you can name this as 16th May, for example, May. I just made it a query, and this can be used for your report generation. Okay, so I'm going to tools, report, define your report. Very important while defining a report. I went to tools, report, generation. I want to just tell report name. So I'll rate as 16th May report. This is what the report is all about. So report, what you want it in report? I want in electrical workbench about bundles which I'm using currently, about the bundles. What do you want in the report? I want the name of that. Yes, you can add that as an attribute, and I want to have the fully connected that as an or I'll take it as a length. I will take this as length as a second factor, add it, and I can take diameter as one more parameter, and I can add even the fully connected. So I'm just selecting each and every parameters, whatever you wanted it. And you remember that we created a query there, and you can just call this query for you. We created a 16 May query just now. So just give it and give OK. Give OK. And this is what you get it now. Okay, twice it has come. Clear it. I'm going to clear it. This one. Add. So save this. So user needs to define attributes. Okay. Okay. Sorry. I do it once again. Bundle segments and name. I'm going to add that, and I'm going to create a length. I'm going to add that. I'm going to create a diameter, and I'm going to add that, and I'm going to create fully connected. Add that, and I'm going to give a name called 16th May the report. Okay, and I'm going to add this query and save this. So while saving, it will be asking what format you want it. So always it takes it a XML format, okay, which you can put it on the test, and I'm going to put it as 16th May, sorry, 16th May as one of the XML format. So now what we defined is my report, what it wants. I defined it. So I need to generate that report. So what I'm going to do, I'm going to generate the report. Using what? The XML file which we created probably. Okay, so go to test, the XML 16 May is there, and just give OK. Probably this video will be given to you. Probably you can use it down the line for practice. Okay, so you can see that I have all the bundle information, length, diameter fully connected. This is what I wanted, right? So which I got it. So Now you can save this, whatever format you want. So you can save this as CSV format in the text. Say for example, 16th May report generated, report generated. Okay, so I'm going to save this and give OK. So this is how we are going to do it. So I'll just repeat once again. Report, for report we need to define it report. For defining a report we need to have a query. For defining a query we need to have attributes. That's what we did it. Query is nothing but control of, where you create a control. And the definition of the report will be saved in the form of an XML file, and later that XML files, using that XML file, I'm going to generate a report. Okay. So now I'm going to call this into a drawing sheet. This flattening, I'm going to call this into a drawing sheet and showcase how exactly it is going to work out. So I'm going to find a new drawing sheet. Okay. And I'm going to show in A0 size. For example, I'm going to select my format template, and I'm going to show here my front view. I'm going to select here this, sorry, I'm going to select my front view, and I'm going to select this particular face. This is my face here. So once I select it, it comes to my drawing sheet. Okay, where I can rotate this drawing sheet. Okay, so this is my drawing sheet, which you saw that just now, the entire information. Okay, so the first thing is I want to understand the reports which we have generated just now. So the reports which we have generated just now is in a CSV format, which I'm going to import it. So go here, you have something where we have created test 16th May, where you can just get into this and placed on this. So you get this information. So you can see this is what the manufacturing team wants it. The manufacturing team wants just a bundle information, the length, the diameter, whether it is fully connected, whatever the attributes you want to add, you can add it. Now we did something called, at the initial stage, we did something called text template creations, all right, where you can import the information of your 3D information. So already I created some data, so where I'll just go to my 3D text template, where you have this 3D text template. This is very important, 3D text template. Select that one, and I've selected this template. So I'm going to this information, and this is my text template. So just observe here, when I select this bundle, so it will ask what you want it. I want the full information, so give OK. So you can see that this bundle dimension information has been recorded. So now I want this bundle information. So just get into this 3D text template and click on this one, provided you need to locate the catalog where you have saved it. Okay, so this is the template from where I'm taking it. So I'm just closing that. So just click on that, and it gives what information you want. I want bundle segment full information. See, it gives OK. Now just let us compare it. Bundle segment 1, 2, the length is 8.0, and the diameter is this, and the length is 18.067. So that's what you see here in your CSV table. So the indirect way or the format of representing your drawing information is all about creating your 3D text template. So you remember the initial stage, the 3D text template created, put it in a catalog, and now I'm calling that one. Okay, so to understand what is the diameter or what is the definition is all about. So this is how you create a report, and this is how the manufacturing team wants a report, and this is how you create a full detailed information. Okay, so okay, so I'll just go back to a PPT where I'll just tell you the entire flow, what we did it. So this is what we did it. I'll just show you that. Just to replay. Before closing, I want to teach you one more, I want to give you just information about what is knowledgeware advisor or knowledgeware expert, which we promised last session that to cover up. I'll just tell you that one. So this is what we did it. We just extracted the harness, we just flattened it with reference to one board, and then we named it in a drawing sheets. So this is what we did. We understood all the algorithm, how we had done that. So just to recapitulate that, this is how the flattening parameters are done. So these are the informations which you can do it, synchronizations. How to generate a report. This is what we did it. Creating a definition report, generating a report, then finally putting the results. Okay. So before closing, I just want to show you one of the thing which we promised, how to use knowledgeware advisor to find the loop. Okay. Final one before we closing it. Okay. So after that, you can ask me any queries you have it. Okay. So before that, I'll just complete this one. So I'm just opening this one. So here you have a component where harness is done already. So you want to understand how the harness is done or not. So here I'm going to create a rule-based modeling. So that's what we do in knowledgeware expert. So knowledgeware expert, you can see here in equipment, in knowledgeware you have expert. So in this knowledgeware expert, you can able to create all the components. So already I have created a rule set. I'll just create a rule now for you. I want to see in this particular harness whether all the harness are fully connected or not. So you cannot see each and every individual. So what I'm going to do it is I'm just going to create a rule. So this is a rule which I'm going to create for now. So one is my name, and this is the rule being created by me today, and I'm going to give OK. So what I want to do it, I want to check here whether my bundles are fully connected or not. So what I'm going to do, this is syntax, B and S, I'm going to give it, colon. So here you have something called as object browser. Okay, you have something called as object browser where you need to go there, and here I want to check for which module, electrical. I have clicked on, you can see there here in the dictionary format, in the dictionary first one I made it electrical. In there I made it bundle segments. Okay, so I'm just going to click bundle segment and give OK. So here I'm going to create BNS, and in this I want to find what in electrical, in bundle segment, I want to check fully connected or not. So I'm just going to click fully connected here. Here, fully connected. I'm going to make it is equivalent to true. True. Close it, apply this, and give OK. So now I'm just going to update it. Just see it comes like a traffic signal in the left corner on your specification tree. Now you don't know what is the challenge. Some particular loom, it is a challenge. So what I'm going to do, I'm just going to click here and find out which is the harness which is having an issue. You can see that reframe on. Just reframe on, it will tell you that this particular harness is not joined here. So you can see that. Okay. So now what you need to do it is that you can just see the report. You can just generate a report. Now it tells you that your report is just 93% because one of the bundle is not connected properly. So I need to just do the modifications. So now you know that this particular harness is not connected to that. So let me work on that so that I'll just remove this bundle definition, and I will remove, I know that this is a particular problem where you have removing that, and I'm going to just connect to the bundle like this for this connector. Okay, so now what happens is your harness gets connected to there, and give apply and give OK. Okay. So now if you see, I'm just getting into my rule set. So you just update once again, and you see your traffic signals turns green. That means you don't have any issues with your harness curve. So this is an easy way of creating a rule-based modeling where you can able to see how the harness has been created. And now you can see the report. It's all about 100%, which we just not covered. So what we learned from this is that Knowledge-aware expert is a rule-based model where you can set a set of queries and you can just try to run those queries and try to find out where the challenges are there. This can be done using QChecker also, which is a very good GUI. If you don't have a GUI like QChecker, you can use knowledge-aware expert, which will guide you at each and every stage. So thank you very much for listening. This is my time up, so I just taken just a 1 minute more as per plan. So any questions, you can just chat me immediately. Thank you, please.